GCE Advanced Level Chemistry Practical number 20, determination of the concentration of a potassium permanganate solution with the use of standard acidified potassium oxalate solution. In this practical, we aim to give you the necessary knowledge on how to prepare a known concentration of a standard solution, and then we will move on to how we can determine the concentration of a permanganate ion solution through a redox titration. Now, let's move on to the reagents we will be needing for this practical. These are the reagents and the equipment we will be using for this practical. We will be needing a beaker, a funnel, a 250 milliliter volumetric flask. We will be using a potassium permanganate solution with approximate concentration of around 0.02 moles per decimeters cube. We will be using a wash bottle, a pipette, and a pipette filler. We will be using potassium oxalate, the white powder you see here. We will be using a watch glass to measure the potassium oxalate, spatula, 3 titration flasks, a retort stand that you see over here. We will be using a spirit burner with a tripod and a wire mesh. And finally, to carry out the titration, we will be using a burette as well. To measure the mass of the solid, we will be using a digital balance that we have here. So, those are the equipment and the reagents we will be using for this practical. Let's move on to our practical. Now, let's move on to our practical and start weighing potassium oxalate. But before we get on with it, I would like to let you know why we have to titrate a potassium permanganate solution before we use it in other titrations. Now, as you may know, potassium permanganate is not considered a primary standard. Why is it not considered a primary standard solution? Mainly, potassium permanganate is not obtained in a very pure form. It contains a little bit of KMnO4, which takes away from the quality of a primary standard. As well as when you are leaving potassium permanganate solution after you prepare it for a while, if you leave it to stand for a while, it has the ability of getting decomposed if it is exposed to sunlight. So, we do not want a standard solution formed with such substance. So, we will move on to other substances like potassium oxalate over here, which has a high purity, which is a very stable compound, and it has a very good equivalent mass, and it is relatively cheap, and we can actually find it with relative ease. So, we will be using potassium oxalate as a primary standard in this practical. However, potassium permanganate is a desirable titrant because it will give you a color change. It acts as a self-indicator, so it will give you a nice color change at the end of titration, and we prefer to use potassium permanganate. If it is standardized, we can use it for titrations to determine the endpoint without having to add an additional indicator. With that knowledge, let's move on to measuring the mass of potassium oxalate needed for this practical. We need to prepare a potassium oxalate solution with a concentration of 0.05 moles per decimeters cube, and the volume of the solution that we are preparing is 250 cubic centimeters. So we know concentration is equal to number of moles divided by the volume. Using that equation, we can find out the number of moles of potassium oxalate that we will be needing for this practical. And then if you know the molar mass of potassium oxalate, you can use the number of moles and the molar mass and calculate the mass of potassium oxalate needed for this practical. So we have already done the calculation. The mass of potassium oxalate that we need for this titration is 2.08 grams. Let's move on to measuring that 2.08 grams. We will turn on the digital balance we have here, and we will use a watch glass to measure the potassium oxalate. So we will place the watch glass over here. We actually do not need to know the mass of the watch glass because since we are using a digital balance over here, we have the option of removing that weight or by tearing, using the tear function over here in the digital balance. Now the mass of the watch glass is disregarded. You can see the scale reads 0.00. Now I will take potassium oxalate and take a spatula full of potassium oxalate and transfer 2.08 grams onto the watch glass. You have to take your time and carefully measure exactly 2.08 grams. As you can see, we have now measured 2.08 grams of potassium oxalate. We can now move on to transferring this 2.08 grams of potassium oxalate onto a volumetric flask. And while I was measuring, I got reminded of a very important characteristic that a primary standard should have. That is, primary standards should not be hygroscopic, which means it should not absorb water from the surrounding or from the atmosphere. Normally, whenever you are weighing a hygroscopic substance, you can see that it absorbs moisture from the air and it starts to dissolve on the watch glass itself. This is not a good feature for a primary standard, so anything that is hygroscopic is not a good choice for a primary standard. And potassium oxalate is not hygroscopic, so that is actually perfect for a primary standard. So with that information, now we have measured 2.08 grams of potassium oxalate. We will no longer need the balance now, we'll keep it aside. And now we will move on to transferring this solid onto our volumetric flask. Let's move the balance out of our way. To transfer this solid completely onto this volumetric flask, we will be using a funnel. We will open the volumetric flask, we will remove the stopper, and we will place the funnel on the volumetric flask like so. And now I will transfer this solid onto the volumetric flask with the use of a wash bottle and some distilled water. So you have to wash the solid onto the funnel, making sure no solid remains on the watch glass. After you wash one side of the watch glass, you have to turn it around and wash the underside of the watch glass. Otherwise, there could be some residual amounts of solids remaining there. So once you do this, all of the solid would be washed and transferred onto our volumetric flask. Let's move on and swirl this volumetric flask around. Try to dissolve all of the solid that we have here before we add more water onto it. You can see when I swirl it around a little bit, most of the solid dissolved. Now you can gradually start to add water. Now all of the solid has completely dissolved. Now let's add water little by little, and we'll make sure that we add water only up to this 250 gradient line that you see over here. So the meniscus of this solution should align with the gradient line that you see over here. So when you're adding the last bit of your distilled water to make this solution, please make sure to raise the volumetric flask up to your eye level so that you can see the gradient line at your eye level. And then you can slowly start to add water very close to the gradient line, and then we can move on to a dropper to more carefully add water drop by drop. Now I will be adding water drop by drop onto this volumetric flask. Now the volumetric flask gradient line and the bottom level of the meniscus of the solution perfectly aligns. So if you are unable to hold the volumetric flask straight, what you can do is you can place it on a table, and you will have to bring your eye level down to that gradient line, and then observe if you have actually prepared the standard solution properly. Right. So now we can see very clearly that the gradient line and the bottom level of the meniscus of solution is in perfect alignment. If you have added a little bit less water, or if you have added a little bit more water, you would have actually not created a perfect standard solution. Especially if you have added additional amount of water, you have to discard this entire solution and you have to start over. So after preparing the solution like that, so we are not yet done. We have to close the stopper quite tightly, making sure there won't be any spillage. And then you can start mixing it around, but since there's a lot of water filled over here, the best way to mix it is close the stopper really tightly and then turn this volumetric flask upside down. You can do it a couple of times to make sure that all the contents are properly mixed. Once you have turned it upside down a few times, like so, you can be sure that everything in here is now properly mixed and you have prepared a homogeneous solution. So this is how we make our standard solution of potassium oxalate with the concentration of 0.02 moles per decimeters cube. Let's move on to our next step. Whenever we are doing a titration, we have to know how to use a burette. So let's first focus on how we can clean a burette and then how we are going to fill a burette up. So what we have here is a burette connected to its retort stand, and before we use this burette, we have to make sure that it is washed with distilled water, and then we have to wash it again with the solution that you're going to fill into the burette. This is to make sure that the droplets of water that is remaining inside the burette does not dilute the solution that is being added to the burette. So to make sure that it is not going to change its concentration, whatever the solution that we add here, that it is not going to change the concentration, we will have to wash this burette twice, once with distilled water, and second time we are going to use the solution that we are adding to this burette, and we are going to wash it again with that solution. So let's move on to washing this burette. Whenever you are trying to use a burette in a lab environment, one of the mistakes that I have seen a lot of students make is that they will keep the burette and the retort stand on the lab desk itself, and then they will place a funnel on the burette, which is over their head, and they will take a solution and lift it again over their heads, which is a bit of a risk in the lab environment, because if you spill it while it's over your head, it will directly get spilled on your face. So we will not do that whenever you are filling a burette. So what you do is you find a stool or a table that is shorter than the lab table, and we will move the burette onto that table. So now the opening of the burette is going to be below your eye level. So now you can take a funnel and place the funnel on the opening of the burette and wash, or actually transfer some water onto the burette. While doing so, please make sure the burette tap is closed. Now I will be adding a little bit of water onto the burette. After transferring some water, I'll transfer some more. After transferring some water onto the burette, to show you all what needs to be done, I'll bring it back onto the lab table. You will take a beaker and open this tap rapidly, making sure the tip of the burette is also cleaned with distilled water. And then we will remove the burette from the retort stand, and then we'll make sure that we don't spill a lot of water, and then we'll turn the burette sideways and wash the interior walls of the burette by rotating the burette like this. So while doing this, you can remove the water onto another beaker to discard the water that was used to wash the burette. You can open this end to make sure all of the water in the burette is removed. So that is how you would normally wash a burette using distilled water. This is just the first step. After using water and washing it, we will have to use the solution that is going to be filled into this burette and wash this burette again with that solution. So let's move on to that. So in order to do that, I will take the rheostat again and fix this burette like this. And then transfer some of the solution that will be used to titrate, or that will be used to fill this burette in the titration. And now again, I will have to take this burette onto a stool that is shorter than the table over here. And I will use a funnel again to transfer some of this solution into this burette. Again, when you're transferring any liquid into the burette, make sure that the tap or the burette tap is completely closed. Otherwise, while you add, you will be making a spill due to the tap being open. Now I will move this back onto my table. Just like in the previous setup, I will open this tap and make sure that the tip of the burette is also fully cleaned. So I will open it rapidly, allow some solution to run through. So now I know even the tip is completely washed. Afterwards, I can remove this burette from the stand and continue to wash it like I washed it before. So let's remove the burette from the stand. Now, like in the previous example, I will be turning this sideways like this and making sure the entire interior surface of the burette is completely washed properly with the solution that is about to be filled into the burette. With this, the washing of the burette is complete. One additional step would be to open the burette and let the remainder of the solution run through. Now, burette is completely washed. We can move on to the experiment. After washing the burette, we will again fix it onto our burette's retort stand, and we will move it back onto a shorter table. Since the washing of the burette is complete, now we will be filling up the burette with a solution that goes in the burette, which is 0.02 moles per decimeters cube concentrated potassium permanganate solution. So let's add that solution onto the burette. So for that, we will require a funnel. We will place the funnel over here. So after placing the funnel, Let's take another beaker and transfer some of the liquid or the sample that we need to fill into the burette. Let's take about little over 50 milliliters because the burette can hold only 50 cubic centimeters. And now, after making sure the burette tap is closed, we will start adding the potassium permanganate solution into the burette. When you are filling a burette, please make sure initially when you are adding the solution to add the solution over the zero line. The reason for this will be clear to you in just a second. After adding the potassium permanganate solution over the zero line, you can see that this tip of the solution is still empty, or tip of the burette is still empty. So we need to fill that area as well. So what we do is we open this tap rapidly to make sure that area is completely filled. Now I wanted to show that to you. That is why I brought the burette onto the table again. Now we have to make sure we keep it at eye level and bring the solution down onto the zero line. So let's do this together. So in this burette, we have the solution level above the zero line, and we have to make sure that the meniscus of the solution over here aligns with the zero line of the burette. So especially when it comes to a dark colored solution like this, finding the zero line could be difficult if you are doing it in a dark environment. So please make sure that you have some sort of light source behind the burette so that you can place or find where the zero line is easily. So let's open the tap of the burette and bring the solution line down to the zero line. And please notice that I try my best to keep my eye level with the level of the meniscus. This is done to make sure that the meniscus and the zero line are aligning perfectly. The zero line is over here. I'm not sure whether the camera can capture the meniscus, but meniscus is aligning with the zero line that is present in the burette. Right. So now I have removed some solution and made sure the meniscus of the solution is perfectly aligning with the zero line of the burette. With that, we have finished. We have actually now finished filling up and cleaning the burette. Now the burette is set up for our titrations. Now we will be moving on to filling up our titration flasks to carry out the titration. To prepare the solution that is going to be titrated against potassium permanganate solution that we have, we need to measure exactly 25.00 centimeters cube of the potassium oxalate solution that we made earlier. So in order to do that, we need to first wash our pipette. So let's move on ahead and wash our pipette. We need to first of all wash it with a little bit of distilled water to remove any impurities that is currently having, and then we need to wash it again with our potassium oxalate solution. Before we fill this pipette with potassium oxalate solution, we have to do those two things: wash it with distilled water and then wash it with potassium oxalate solution. Let's go on ahead and do that now. Here we have our distilled water. We will take our pipette and use a pipette filler such as this one, and we will press the topmost valve over here and squeeze the pipette filler and try and take in a little bit of water with the use of the second valve that you have over here. As you can see, when I am pressing it down, pipette is getting filled with water. Now, after you have taken in sufficient amount of water into the pipette, we can remove the pipette filler like this, and then we can turn it around and let the water go. After a while, we can let the water go out of the opening of the pipette. Now I have taken distilled water into the pipette once and let it out, making sure that I have washed the interior walls of the pipette with distilled water. All that is left for me to do now is to take our potassium oxalate solution and wash it with our potassium oxalate solution. Let's take a small beaker and take our volumetric flask. Now this is a potassium oxalate solution that we prepared earlier. We have to make sure that you do not put the pipette into the volumetric flask. That is not a good practice. So we will withdraw a small amount of potassium oxalate onto a different beaker. Now let's transfer adequate amount of potassium oxalate onto a small beaker. We'll fix the pipette filler again like so. We'll again squeeze out the air in the pipette filler, and then we'll place the pipette filler into the beaker like this, and we'll draw in some potassium oxalate solution. After taking an adequate amount of the potassium oxalate solution into the pipette, as you can see, I'm keeping my thumb over here to make sure the entire solution doesn't fall back into the beaker. You can take the pipette out and keep it horizontally like this and turn it around, making sure all of the interior walls of the pipette is completely coated with potassium oxalate. Once you are done, you can take another new beaker and discard the solution that you used to wash the interior of the pipette. Now we have completed the washing of our pipette. Now we can move on to taking some amount of solution into this pipette. We'll use this pipette to transfer exactly 25 cubic centimeters of potassium oxalate onto our titration flask. So we will have our titration flask here. Since we have to measure exactly 25.00 0.00 cubic centimeters of potassium oxalate, we have to make sure that we use our pipette and then measure exactly 25 cubic centimeters of potassium oxalate. As you can see, with the help of the pipette filler, you are able to measure exactly 25 cubic centimeters. Now, when you are using a pipette filler like this, you have the option of drawing in more water like this, and you can release some water with the help of these two buttons over here. These are actually valves. You can see when I press this valve, it will draw in some water, or actually the solution over here, and when I press the other one, it will allow the solution to run back into the beaker. So while using these two buttons over here in the pipette filler, I will make sure that I draw only up to the gradient line that we have over here. As you can see, the bottom level of the meniscus is in alignment with the gradient line of the pipette. This means that we have measured exactly 25 cubic centimeters of potassium oxalate solution. Now we can safely take this pipette and make sure the tip of the pipette is touching the interior wall of our titration flask, and then we can allow the liquid to run down into the titration flask. Right. After transferring all of the liquid, please make sure not to force this last droplet that is present on the tip of the pipette. This tip is supposed to be there on the pipette because the pipette is calibrated in such a way that this droplet over here on the tip is supposed to remain on the pipette itself. So do not force it onto the titration flask. If you do that, there will be an additional drop added onto your titration flask, and it will give you a measurement that has a significant error in it. So we do not want that to happen. So please make sure that you don't force that droplet into your titration flask. After measuring exactly 25.00 cubic centimeters of our potassium oxalate solution, we have to add 15 cubic centimeters of dilute sulfuric acid. Now, when you are measuring the dilute sulfuric acid, we do not have to use a pipette because we are titrating potassium oxalate. Addition of dilute sulfuric acid is done just to make this solution acidic. We do not need to measure the volume of sulfuric acid that precisely. So we can use a measuring cylinder. We do not have to use a pipette. We will be using a measuring cylinder to measure 15 cubic centimeters of sulfuric acid. Each time whenever you make a measurement, especially using a measuring cylinder or a burette or a pipette, you have to make sure that you bring the meniscus to your eye level to see if you have measured it properly. After you measure exactly 15 cubic centimeters of dilute sulfuric acid, we can transfer it into our potassium oxalate solution over here. And now we will give it a little swirl. We'll swirl the solution around a little bit, and then we have to go on ahead and heat this solution. So in order to do that, we will be using a spirit burner and a tripod and a wire mesh. So we will light the spirit burner first. After lighting the spirit burner, we can place our tripod and a wire mesh like this. So it is important to make sure that we place a wire mesh because it will help in distributing the heat evenly and making sure that the heat that is provided by the spirit burner is received by the beaker, or in this case a titration flask, evenly. So we will place the titration flask over here and allow it to warm up for a few minutes. And then now we will be moving on to filling up our burette with the potassium permanganate solution. All right. Students, now we have washed this burette with distilled water and the potassium permanganate solution, and we have filled it up to the zero line in the burette. So now we can move on to our titration. As you can see, we started off with heating our solution in our titration flask. This was done because this reaction we are about to do progresses very slowly at room temperature. So by heating it up, we make sure that the reaction takes place at a faster pace. So now let's start our titration. We are expecting the color of this potassium permanganate solution to remain stable for a while, but as you can see, once you add a little bit of potassium permanganate and when you allow it to react with the solution a little bit, with time it completely disappears. This is because the potassium permanganate reacts with the oxalate anion and converts MnO4 minus into Mn2 plus. MnO4 minus is a dark purple color with a high color intensity, but when you turn MnO4 minus ions into Mn2 plus, the color of Mn2 plus is a almost colorless color. So basically, we looked at in the previous practicals, we looked at the colors of Mn2 plus aqueous solutions. It is supposed to be a very slight pink color. However, we do not necessarily observe that color in lower concentrations of Mn2 plus. So what we are seeing here is a disappearance of this dark purple color when MnO4 minus ions convert into Mn2 plus ions. When this is happening, since MnO4 minus is a good oxidizing agent, it oxidizes the oxalate anion and converts the oxalate anion into carbon dioxide. As you can see, when we add potassium permanganate, the color of the potassium permanganate disappears completely. We need to do this titration while heating the solution constantly. So if the solution cools down significantly, we will again place it on our heating mantle over here, and we will heat it a little bit to make sure that we carry this titration out at a higher temperature than room temperature. When we are doing a titration like this, we can see when we add a little bit of potassium permanganate, how long it takes for the color of the potassium permanganate to disappear. If the color of the potassium permanganate disappears quite fast, that means we are not very close to the end point. If it takes a little while longer, that means we are nearing the end point. But when it comes to this particular titration, it could mean the temperature of the solution also is not enough. At that point, we can try to heat it up again and see if the color disappearance takes place at a faster rate. The solution seems to be cooled down a little bit. So let us heat it up a little bit more. Again, the reason why we are heating up this solution is because this reaction between potassium permanganate and the potassium oxalate in acidic medium happens at a slower rate at room temperature. So we need to make sure that we increase the temperature a little bit for this reaction to happen at a faster rate. So that is why we have placed this again on our spirit burner to make sure that we increase the temperature a little bit more so that the reaction can happen faster, so that we can see a clear endpoint at the end of this titration. Now, let's continue on with the titration. Students, now you can see that we are observing a permanent pink color. Now this color is permanently there due to all of the oxalate anions reacting with the potassium permanganate that we added into this solution. So after all of the oxalate anions are completely reacted, the next oncoming drop of potassium permanganate will make the entire solution a slight pink or slight purple color. So at this point, we can see that we have successfully obtained our endpoint. So after obtaining our endpoint, we need to observe the reading of the burette. So let's go on and take a reading or take a look at the reading of our burette. So our burette reading is at 31.6. So our first burette reading is at 31.6. Just like this titration, we have to do 2 more titrations so that we have enough and more measurements to move on to a calculation, knowing that we did not make a lot of mistakes. So whenever we have 3 measurements, we can be sure that these measurements or the method that we followed was correct, and if the 3 measurements are closely related to each other, we can argue that the measurements are concordant or they are precise, so that we can move on to calculate the concentration of the potassium permanganate in this burette. So let's move on and try to do 2 more titrations against potassium permanganate solution. Students, now we will be doing our second titration. So just like in the previous titration, we have prepared a solution to our titration flask. In order to make this solution, we took 25 cubic centimeters measured with a pipette of potassium oxalate solution, and then to that we included 15 cubic centimeters of dilute sulfuric acid. And as you can see here, we have filled our burette again up to the 0 point, so that when we are doing our titration, we will have enough and more potassium permanganate to carry out our titration. So let's move on to our second titration. Just like in the previous titration, we have heated up our solution, and if we need to heat it up in the middle, we will go ahead and do so. For the time being, it is at a temperature of around 60 to 70 degrees Celsius. So now let's start our titration. Now, you might have noticed that I started adding potassium permanganate rather rapidly. The reason for that is because now, since we have done our first titration, we have an idea where our endpoint would lie. Our endpoint for the first titration was obtained at 31.6 cubic centimeters of burette reading over here. So up until that point, without any hesitation, we can add our potassium permanganate solution onto our titration flask. So let's say till about 25 cubic centimeters, you can add our potassium permanganate rather rapidly. From that point onwards, you can take it slow and add potassium permanganate into this titration flask little by little. So let's go ahead and do that. Students, now I have added about 27 cubic centimeters of potassium permanganate into this titration flask. From this point onwards, I will be adding potassium permanganate little by little into our titration flask. Students, now you can see that the color of this solution is having a permanent uh, pink color. So this permanent pink color again is due to reaching the end point of this titration. Now all that is left for us to do is take the burette reading over here. So if you take a look at the burette reading now, it is exactly at the same reading as before. It is exactly at the same reading as before, 31.6. So the reading of the second titration was also exactly 31.6. This is a good indication, kind of giving us an idea that the titration reading has been precise. That means we have been following the right methods. Our measurements have been somewhat accurate. So let's move on to our third titration and see if we can get similar results for the third titration as well. We have completed 2 titrations. Now let's move on to the third one. So just like in the previous 2 titrations, to a titration flask, we have added 25.00 cubic centimeters of our potassium oxalate solution. We have added 15 cubic centimeters of dilute sulfuric acid, and then we have placed it on a spade burner and we have heated it up to about 60 to 70 degrees Celsius. And apart from that, we have refilled our burette with our potassium permanganate solution that is going to be used for the titration. So with all of this in place now, we can start our third titration. In this titration, just like the second titration, since we know end point is going to be somewhere near 31.6, we can start adding potassium permanganate rather rapidly to about 25 cubic centimeters, and then from that point onwards we will slow down and we will add potassium permanganate little by little to obtain our endpoint more clearly. Students, now I have added about 26 cubic centimeters of potassium permanganate into this solution. Let's start adding potassium permanganate little by little. We are now at 30 cubic centimeters. So you can start adding potassium permanganate drop by drop to clearly identify the end point of this titration. Now we have obtained our endpoint over here. The endpoint over here is signified by a permanent pink color or a permanent slight purple hue that you observe over here in the titration flask, just like in the previous two titrations. So this is an indication that we have obtained our endpoint. All that is left for us to do is taking a look at the butyrate reading at this point. So the butyrate reading at this point is exactly 31.5. So the butyrate reading is 31.5. We are not at 31.6, but 31.5 is still a concordant butyrate reading, because the previous two butyrate readings were 31.6. Both first and the second titration was 31.6, and the third one was 31.5, which is quite precise set of butyrate readings that we have obtained. So with this information now, we can go on ahead and calculate the concentration of this potassium permanganate solution that we have used to carry out this titration. So let's move on to our next session, where we will be discussing how to carry out that calculation as well as some important details about this practical.